So coming to physics, now you have already studied first year and you have already studied second year. So there will be total first year plus second year nearly 30 lessons, 30 chapters. Nearly 30 chapters. Some chapters they are having more weightage, some chapters they will have less weightage. Now coming to the physics, we will see how to deal the questions. The MCQs in the shortest way and a given time, because you left it only 1 minute for each question. Now topic wise we will go and how to take the answers we will see. Now first we will take first one. The first lesson is you will get physics word. What are the invention of C.V. Raman? This is generally asked question. What is the invention of C.V. Raman? There are giving so many options. So, what is the invention? C.V. Raman, sir, he gave the scattering of light. Scattering of light. It is his discovery and it is his invention, the scattering of light. That means the light is absorbed by the molecules present in the atmosphere. That light will be given in all directions with a different intensity. That is called scattering of light. So, what is the invention of C.V. Raman, sir? This is scattering of light. Scattering of light. Now we will come to the second question. What is the dimensional formula? What is the dimensional formula? What is dimension? What is meant by dimension? So, dimensional formula means you have to represent length, mass, time. L means length, M means mass, T means time. All this put together makes the dimensional formula. Now let us see how to write the dimensional formula of speed. So, what is meant by speed? Speed is equal to distance by time. So, distance or length both are same. So, distance will be represented by length and time will be t. So, speed is v. So, v is equal to L by t. That is equal to L to the power 1, t to the power minus 1, and m should also you write m to the power 0. M to the power 0. So this is the dimensional formula of speed. So here you have to write all. You have to write represent length, you have to represent mass, and you have to represent time. In this there is no mass, that is m to the power 0, something to the power 0 is 1. So you can eliminate that. So the formula is L1 t to the power minus 1. Now we will see one more. Now one question generally asked. What is meant by a vector? And scalar. What is meant by vector and scalar? What is the difference? You might have already studied. The thing is, scalar means only magnitude. Only magnitude. Example, length 10 meter. So length 10 meter, the 10 meter is only number, its magnitude, but it is not having anything else. Now we'll see vector. Vector means it will have both magnitude plus direction. It should contain both magnitude and direction. So example we'll see. A car moving with 30 km per hour from east to west. A car moving with here the magnitude is 30 km per hour and the direction is from east to west. If a quantity contains both magnitude and direction, it is called a vector quantity. It is called a vector quantity. Now you have already all noticed that the following are the equations of motion, that is equations of motion. What are the equations of motion? Number one, V is equal to U plus AT. V is equal to U plus AT. Number two, V square is equal to U square plus 2AS. V square is equal to U square plus 2AS. Number three, S is equal to UT plus half AT square. What is meant by V? V is the U is equal to initial velocity. Initial velocity. V is equal to final velocity. And A is equal to acceleration in time t. In time t, S is equal to distance displacement. So these are the equations of motion 1, 2, 3. Where the equations you can apply, where? What are the conditions? You may be knowing this, but where we have to apply the equation? Or for all you cannot apply this equation. These equations are valid, very very important here is valid for one, a body moving in a straight line, with uniform acceleration. With uniform acceleration. These three equations are valid for this condition only. What is the condition? The body must move in straight line and it should have uniform or constant acceleration. Otherwise this cannot be valid. It is very very important. It is very very important. Generally everybody applying the equations. Okay, now we go to some other thing. Sir, proceed. Can